All right, so this is the second page of the practice test. All right, the first one, which function represents a linear function? The thing to remember about linear functions is they have x to the first power, not x squared, which is what this would be if I multiplied it, not any absolute value, not x to the 1/2 or anything like that. That means a radical is a fractional exponent. So we can't have radicals, can't have absolute value, can't have x squared, x to the third. I also can't have x in the denominator. Just a plain old x. One way of thinking of it is if I can't write it in this form where m and b are numbers, even if b is just 0, then it's not linear. The only exception to that would be x equals a number is also linear. All right, number 9. Evaluate the following functions at values a, x is 4, and b, x equals -2. Number 9, this is not a big deal. I just plug in. So I plug in 4 first. -2 times 4 minus 7. And that gives me -8 minus 7, which is -15. And part B, I plug in -2. -2 times -2 minus 7 is +4 minus 7, which is -3. So that's pretty straightforward. It takes a little bit more thought on number 10, because when you plug into a piecewise function, you have to plug in to the piece that goes with the x you're using. In other words, if I'm using x is 4, this part up here is only good for x values less than or equal to -3. That doesn't include 4. This part is only good for x values between -3 and 2. That doesn't include 4. This is the part that's good for x values that would be in the same place of 4, which means greater than 2. 4 is greater than 2. And remember, it's like it says y equals this. So this is like saying y equals 5 for all x values greater than 2. So even though there's no place to plug in the x, I just get 5. So y is 5 when x is anything greater than 2. So that means like the ordered pair 3, 5, 4, 5, 5, 5, etc. The next one I'm plugging in is -2. Again, it's not less than -3 or equal to -3, so it doesn't fit this one right here. It is between -3 and +2, so it goes with this part right here. So I will plug into 2x minus 7. So I get 2 times -2 minus 7. That's -4 minus 7, which is -11. So make sure to only plug into the appropriate place when you're plugging into a piecewise function. You'll only plug into one of these equations. Numbers 11 and 12, these were a lot like the beginning of our quiz on 2.4 and 2.5. Yeah. Okay, so first thing we look at is the sign, and this is just like right here. First thing we look at is the sign to tell if it goes up or down. Okay, so this is negative, so that means it goes down. Number 12, right behind the equal sign, is a positive, so it goes up. The next thing we look at is the number. The next thing it asks about here is to identify the vertex. So that's the pluses and minuses. That's the h and k. Remember, it's like plus or minus a times x minus h plus k. So it's the pluses or minuses inside here and outside here. So this has a -1 inside with x, so that's 1 in the positive direction, which is to the right, because it's always the opposite sign for the x thing. So this means it's going right 1, and then this is up 5. So that means from 0, 0, we go right 1 and up 5, and our vertex is at 1, 5. Okay, finally, if this number, which is kind of like the slope, is bigger than 1, and we're not talking with signs, like completely ignore the positive and negative. If 2 is bigger than 1, which it is, that means it's going to be narrower. Okay, here we have a 1. So that's going to be the same as the parent function. If this had been like, if there had been like a 1/3 or a 4/5 or some number smaller than 1 in front of the absolute value, regardless of whether it's positive or negative, that would make it wider. Okay, vertex here. There's nothing happening to move the x left and right, the vertex left and right, because there's not an x plus something or an x minus something. So that means The x value is at 0. And then this minus 7 means I go down 7, which means my vertex is at 0, -7. Okay? Now, I cannot caution you enough to pay attention to the difference between 13 and 14, which are lines, and 15 and 16, which are absolute value. People are making mistakes with that because they're forgetting how to graph a line or forgetting that it is a line. Please remember that if you forget how to graph anything, you can always just plug in points. You can pick an x, plug it in, see what y you get, and make that point on the graph. And then do it again with a different x until you have enough points to see what the shape is. That's always true, whether it's a line or absolute value or anything. But additionally, so I could do this as a table of values. I could do x, y, and just pick values and plug in the x's. I would probably, you don't have to, but I would probably pick multiples of 3 because they're easier to take 2/3 of. Like 2/3 times 3 is 2. 2/3 times 6 is 4, and so on. But you don't have to do those. You could do just this. Any x values you want. I'm going to do it by looking at the slope and the slope and the y-intercept. Here's the slope. It's y equals mx plus b. My slope is 2/3. That means I go up 2 for every 3 I go to the right. And my y-intercept is 1. So that means I'm going to start at 1 on the y-axis because that's where I know my graph crosses the y-axis. And then I'm going to go up 2 and 3 to the right from there. And up 2 again and 3 to the right from there. And so on. Up 2 and 3 to the right is the same thing as down 2 and 3 to the left, by the way, because the line goes in both directions. So there's my line. The other line here is a horizontal line, y equals 5. Another way of thinking of that is this is the set of all points where the y value is 5, regardless of what the x value was. So in other words, -2, 5, 1, 5, -1, 5, 0, 5, 1, 5, 2, 5, 6, 5, -10, 5. Any value I want for x, the y value is 5. So no matter what point you pick for x, the y value is 5. That's going to be a horizontal line. And it looks like that. Okay, now when you get to 15 and 16, if you see absolute value and you're graphing, you must expect a V. Okay, absolute value graphs always are a shape of a V, either an upside down V or a right side up V. One of the two. I can tell right now because this has a positive, it's right up. I mean, it's upside, right side up. It's going to be like this. Because this has a negative, it's going to be like this. So that's the first thing I notice about those two. I think the easiest way to graph would be to go first to the vertex. So I'm going to start with the vertex, which sometimes we call HK. Okay, the H is the opposite of the number I see in here with X. So this means H is -3. The K is the number I see plus or minus in the back behind the absolute value. If I don't see anything, that means it's plus 0. So it's just -3, 0. So here's my vertex. It's at -3, 0. Now I'm going to look at this 1/2 because it's kind of like my slope. Okay, but a V shape has two sides. One of them has positive, one of them has negative, so it really doesn't matter whether we're careful about the signs at all. It's just a matter of how far does it move up and down for every how far it moves left and right. So I'm sorry, I went the wrong way. Thank you. Okay, so here's your vertex. Thank you. Okay, so this is saying I go up 1 for every 2 I go to the right or left. Okay? And the reason I know it's 1 basically, I mean up, is because I know this opens up. So I'm going up from here. So up 1 for every 2 I go to the right, up 1 for every 2 I go to the left. So up 1, right 2, up 1, left 2, up 1, right 2, up 1, left 2. Again, if you get confused at all about how to graph, please don't forget that you can plug in points. You can make a table of values. So I could always just say, okay, I'm going to pick an x like -5, and I'm going to plug it in to 1/2 absolute value of x plus 3. So you can do that every time. So I could do -5 plus 3 is -2. Absolute value of -2 is +2. 1/2 of +2 is just +1. And so -5, 1 is the point that goes on my graph. And you just do that enough times so that you can see what the shape is, but remember to expect a V. Because it's not like if I just did these points over here and didn't realize I needed to expect a V, I might think it's a line and keep drawing down here. I need to make sure I understand that I'm looking for where it turns, because it's going to be a V.
So absolute value is V.
Absolute value will always be V. V is for value. Okay, it could be upside down though. All right, so this one's upside down. The vertex is at +4, +6. Y'all see that?
Mm-hmm.
So I go to +4, and I'm being careful that I go the right direction this time. And there's my vertex. And the slope being 3, or this number right here being 3, says that I'm going to go either up or down 3 for every 1 I go to the right or left. Now, if I know this is the vertex, and I know it's pointing down, I'm going to be going down 3. So I'm going to go down 1, 2, 3, and right 1, or down 3, left 1. It works both ways, because it has 2 sides, and they go in opposite directions. One has a positive slope, one has a negative. 3 over 1, down 3 over 1, and this is my pretty little V. Again, if you get confused about where it's going, plug in an X, find the Y, and put a point there. Plug in a different X, find the Y, and put a point there, and so on.